Good morning, students. I welcome you all for today's session, that is Turing Machine. Right? So, if you see the basic block diagram of a Turing machine, it is just like a finite control which you saw in your DFA, where it has an infinite tape, right? But it is one way, but this is two way, right? Okay, so you can say it has two stack combined like that. So it also has one finite control. The initial value of the tape in the Turing machine will be blank, right? Right, a move of Turing machine includes change state, and you will be having a tape symbol in the cell that is scanned, that is red. You are moving the tape head from left to right. The formal definition of Turing machine is 7 tuple, where Q is a finite set of states of the finite control, sigma is a finite set of input symbols, and tau is a set of tape symbols with sigma being a subset of it, right? Then delta is a transition function. Now delta of q comma x, we are having three resultant points in the resultant state, well here q is the current state, x is the tape symbol. After you see the tape symbol, what is the resultant state? That is p. Are you changing the tape symbol content? The tape symbol written on the cell being scanned, okay? Are you replacing it or you are leaving as such? And D stands for whether you are moving forward or backward, in the left or right. So it moves, it says the direction of the move of the tape head, right? So the formal definition, right? So Q naught is a starting state, B is a blank symbol in the tape, not in sigma, and F is a set of final or accepting state. Now a Turing machine is a deterministic automaton with a two-way infinite tape which can be read and written in either direction. Let us see the instantaneous description for Turing machine. The instantaneous description idea of a Turing machine is represented like this. X1, X2, X3, these are all the portion of the tape between the leftmost and rightmost blank symbols. And Q is the current state. The tape head is scanning the ith symbol Xi from the left. Let us see an example. Now design a Turing machine to accept the language L is equal to 0 power n, 1 power n, where n is greater than or equal to 1. My dear students, you all should remember that in PDA also we have seen the same 0 power n, 1 power n example. Now we are going to start at the left end of the input. That is, this is the logic for your Turing machine. In the case of PDA, you push all zeros and for each one you pop each zero. So finally, when you reach the end of the input string, your stack content will be that bottom of the stack value Z0. Now in Turing machine, let us see the algorithm. You are starting at the left end of the input. You change 0 to an X. Move to the right over zeros and Y's until a 1. Now you change 1 to Y. Move left to over Y's and zeros until an X. Because in Turing machine, you can move forward as well as backward. Look for a 0. That is, you match for every 0, every 1 by replacing 0 by X and 1 by Y. Once again you move backward, you convert 0 to X, and once again you find a pair for it. This is repeated, right? If a 0 is found, change it to X and repeat the above process, right? The various programming techniques for the Turing machine are storage in the state, multiple tracks and subroutines. One of the best example for our subroutine is our multiplication, where we are calling, that is, every time when you find a match, right, the multiplication, no, you will be having a separate subroutine. Now let us see it. Now extensions to the basic Turing machine, right? So now you can instead of having one two-way infinite tape, I can have more than one tape. So you have multi-tape Turing machine, right? So because of this multi-tape Turing machine, you can use this Turing machine in various applications, right? Now initially the input string is placed on the first tape, the other tapes hold all blanks. The finite control is in its initial state. The head of the first tape is at the left end of the input. The tape heads of all the other tapes are at arbitrary position. A move consists of the following steps. The finite control enters a new state. On each tape a symbol is written. Each tape head moves left to right or stationary. So let us see an example in the next class, students. Hope you all understood the basic definition of Turing machine. Thank you, students. Take care. Bye.